All right, a lot of times in geometry, if we're given a particular segment in the coordinate plane, it's helpful to be able to identify and write the equation of a perpendicular bisector. Let me just show you what that looks like graphically, and then we'll look at the algebra. Graphically, when we look at this, I have segment AB in the coordinate plane, and I'd like to know the equation that represents the line, which is the perpendicular bisector of AB. You know that that line passes through the midpoint, and it would look more or less like this. And of course, that line is perpendicular to segment AB. So that's the graphical representation. The question now is, how do we do this algebraically? How do we identify the equation of this line right here? That's what we need to accomplish. Let's look at this example. It says identify the perpendicular bisector of segment AB given A at 5, 4 and B at 7, 12. So the first thing we do, step number 1, is find the midpoint. Since we know the perpendicular bisector always passes through the midpoint. So let's find the midpoint. We use the midpoint formula for that. In this case, it looks something like this. 5 plus 7 over 2, and 4 plus 12 over 2. Remember, the coordinates of the midpoint are simply the averages of the coordinates of the points. And so my midpoint is equal to 12 divided by 2, which is 6, and 16 divided by 2, which is 8. So that is my midpoint. Notice the capital M, that will be important in just a moment. Step number 2, find the slope of the given segment. I need to find the slope of segment AB. And to do that, we just use the slope equation. This is lowercase m, is equal to my change in y, 12 minus 4, over my change in x, 7 minus 5. And so in this case, it's 8 over 2, which is simply 4. So the slope of segment AB is 4. Step number 3, find the perpendicular slope. Since we know the perpendicular bisector has a slope which is perpendicular to that of the given segment, we just need now to find the perpendicular slope. Well, if the slope of my given segment is 4, then the perpendicular slope is negative 1/4. Step number 4, use the slope and the midpoint to write an equation of the line that is the perpendicular bisector. The easiest way to do this, it may be tempting to use point-slope form, and that would work perfectly fine. But in this case, it may be easier just to use slope-intercept form, y equals mx plus b. Let's look at that. So y is equal to 8. M is negative 1/4. X is 6. And we're adding b. B is our variable still. Once we solve for b, we'll be able to put the information back into this form, and we'll have our equation. So, let's multiply negative 1/4 times 6. That's equal to negative 6/4. And negative 6/4, of course, is negative 1.5. So we need to add 1.5 to each side. And we end up with b equals 9.5. Now that we have b, we can take b and slope m and put them back in this form. Y equals m, which is negative 1/4, times x, plus b, which is 9.5. So that is the equation of the perpendicular bisector with respect to segment AB given these points. These are the 4 steps. Find the midpoint, find the slope of the given segment, find the slope of the perpendicular segment or line, and then write the equation of the perpendicular bisector. Let's look at one more example. Okay, the problem says identify the perpendicular bisector of segment AB given A at negative 1,8 and B at 5,2. First thing, let's find the midpoint. So it's negative 1 plus 5, which is 4, over 2 is 2, and 8 plus 2 is 10, divided by 2 is 5. That's my midpoint. Next, let's find the slope of the given segment. It's a lowercase m. This is 2 minus 8, which is negative 6, divided by 5 minus negative 1, which is positive 6. So my slope is actually equal to negative 1. Find the perpendicular slope. The opposite reciprocal of -1 is +1. Now, write the equation of the perpendicular bisector using the slope we just identified and the coordinates of the midpoint. Again, one way to do this is to use the form y equals mx plus b. You could use point slope form, that'd be perfectly fine. So y in this case we have a 5, slope is 1, x is 2, plus b. We can now see that this is 5 equals 2 plus b. Subtract 2 from each side. 3 equals b. And finally, we'll take that b and that m and put them into an equation that's in slope-intercept form. Y equals slope, which is 1, times x, plus b, which is 3. And this, of course, is not necessary. Y equals x plus 3. That is the equation of the perpendicular bisector of the given segment that passes through -1, 8, and 5, 2. I would like to take just a few moments and run through this part of the process using point slope form instead of slope-intercept form, just because I think it'd be a good review. Y minus y1 is equal to m x minus x1. That is point slope form. Now we plug in the values that we know. Here's our point, here's our slope. Y minus 5 is equal to slope, which is 1, times x minus 2. Y minus 5 equals x. 1 times x is x. 1 times -2 is -2. We need to add 5 to both sides. Y equals, this cancels, x plus 3. Okay, as you can see we end up with exactly the same answer either way. You can use the slope-intercept form, you can use the point slope form, either way you'll get there. As always, if you have any questions, please send me an email.